Okay, so I'm continuing with question 5.2.1. In the previous video, I did 5.1. Now it's 5.2 of this financial mathematics question. It says Harry buys a property for 1.5 million, and after paying a deposit, he takes out a loan for the remaining amount of 1.275 million. So this is my the price of the house. He takes out a loan for this after paying a deposit. Now I can see from this, if I subtract them, that the deposit should be 225, and then it says the remaining amount of that at an interest rate of 9.2% per annum compounded monthly over a period of 20 years. The monthly installment on the loan is 11,636.2 cents. And then they want you to calculate the outstanding balance of the loan after 7 years. Okay, now there's various methods to calculate outstanding balance. So if you have another method than the one I'm using, that's fine. But if you don't have a method, you can use this method. And basically, to calculate the outstanding balance, you must calculate the value of the loan so far up until now, so which is 7 years in this case. Okay, so I'm going to calculate the value of the loan so far and then subtract the future value of the installments paid. Future value of paid installments. Okay, so this is what I'm going to do, which the loan so far is following compound interest. 1 plus I to the power of n is following a compound interest for 7 years. And then I'm going to subtract the formula 1 plus I to the power of n minus 1 over I, which is the future value formula of the amounts paid so far, which my n will also then be so far I've paid now for 7 years, basically. Okay, so this is what I'm going to do. I'm going to just change my n to 7 years because that's what I'm really interested in, actually, is 7 years. And since I'm working monthly, I'm going to divide my 9.2 by 12, and I'm going to times my 7 by 12, right, monthly payments. So the amount that I'm working with is the amount of the loan, which is that 1,275,000. My interest rate is 9.2%, which is 0.092. And I'm going to take that over 12 because it's monthly payments. And then my n is going to be 7 times 12, which is 84. And just for space, I'm just going to write down here. And then that my installments, 11,636.02, is 1 plus my I is still 0.092 over 12 for 84, minus 1, and all of this over my 0.092 over 12. Right, so I just substitute this. The amounts that I'm substituting of the all of these amounts that's here is the one that specifically has to do with the loan. And then my interest rate is this over 12. My number of years that I'm working with is 7 because I want the outstanding balance over 7. And I'm working with the amounts paid after 7 years, which would be basically then this of 7 years. And the amount of the loan so far, so the interest that it's accumulated over 7 years, basically. And then I just substitute all of that. And this I'm going to now feed into my calculator. I think I'm going to just feed this and this separately in, just not to overwhelm my calculator completely. 0.092 over 12 to the power of 84, which is very big, 2421,749,124, and then I'm going to subtract 11,636.02, whoops, 0 2 brackets. I just filled this in my calculator exactly, 0.092 over 12. To the power of 84, just make sure you go down, press the button to go down from the 84 before you put in the -1, over 0.092 over 12. Okay, that seems correct. And then that is 13,650. I'm writing so ugly, let's just do that over. 365,073.733, and I'm not rounding off now, although this is amounts, because I first want to do the whole thing. Okay, so I'm going to take the pre-answer, subtract the answer from that, which is then 105675.391, and that can round to 39. Right, so if you want to calculate the outstanding balance of a loan, this is something that gets asked, so it's good to have a method that you can always use. If you have a method that works for you, that's fine, but what I do is I take the value of the loan so far using the compound interest formula, and then I take the future value of the loan of everything that I've paid so far, future value formula to work out everything that I've paid so far, and I subtract that from that, and then that is my answer. Okay, so 5.2.2 says after 7 years due to financial difficulty, Harry misses 5 consecutive payments. Thereafter, he continues making monthly payments into the loan account until the end of the 20-year period. Calculate the value of the new monthly installment to settle the loan. Okay, so he had a loan for 20 years. Now, after 7 years, his outstanding amount is now 0.56675.39. Then for 5 months, he didn't make an installment. But obviously, just remember the loan is going to still accumulate interest for that point. It's not going to stand still. So for 5 months, it's going to accumulate interest, and then he has basically 12 years and 7 months. 7 years, 8 years will be, yes. So for 12 years and 7 months, he's going to make payments, which is 12 times 12 years, there's 12 months, it's 144 plus the 7. So it's basically for 151 payments. He's going to now pay off the loan. Okay, so this is, I'm just going to calculate his initial value just to get you up to speed with the procedure here. I'm just going to calculate the initial amount here, which is a present value then. And then after I've calculated the present value there, I'm going to just use the present value formula with 151 installments. And that amount of interest still. Okay, so let's just go calculate this formula with the starting at the beginning of at the end of the 7 years. He starts with 105675.39, and that builds up still at a rate of 0.092 over 12, and that happens for 5 months. Right, now you can multiply 1 year with 5 over 12, or you can just 12 months over 5 over 12. Okay, it's 5 months. Okay, so 5 months, and that is then 105,675.39, 1 plus 0.092 over 12 to the power of 5. Okay, which basically means now 807.15. Now, after the 5 months that he missed, this is what he basically owes the bank now. Okay, and then he's gonna pay this back now over 155 installments. So I'm going to use the present value formula. Let me just quickly look that formula up also. It looks like this: x1 minus 1 plus I to the power of minus n over I. Okay, so this is the present value formula because this value is presently now the current outstanding amount. So I'm going to use the present value formula. And I want to calculate the monthly installments. So my present value is going to be that 197,807.15. I don't know my x. 1 minus 1 plus, and my I is still going to be the interest amount per month is still this. And then this is now for 151 installments. Okay, the 151 seems weird. Oh, you can't see anymore. Let me just move up the board a little bit. Okay, great. The 151 is basically from this 12 years, 12 times 12, and the 7 months that I add. So this is a bit of a weird concept, but just think of this not really as the number of years they're in like you always did. Just think of this as the number of installments. So if I have monthly installments over 12 years, that means 12 times 12, 144 installments. And if I have another 7 months, then that is 144 plus the 7 amount of installments. I find it better to think about that in as the number of installments and not really the number of years as they start teaching. Okay, now to calculate the x, like we did in question 5.1, I'm just going to $151. Just trying to not let this light shine in your eyes there. Okay, so I'm going to first just multiply with this on that side. So I'm going to take this, I have this on my calculator already. So I'm just going to press multiply by 0.092 over 12. And that gives me 8416,521. I'm going to leave it on my calculator. And then to get the x, I must divide yet again with this whole bracket. So I'm just going to divide, and then I press bracket 1 minus bracket 1 plus 0.092 over 12 bracket to the power of 151, close the second bracket, and I'm done. Okay, now weirdly enough, let me just check if I've done this correctly. For some reason, this gives me a negative number, which I can't think that I have a negative installment. They shouldn't pay me money. Not that I can think of. So now I'm wondering either I did something wrong. Oh, I had the formula. There's my mistake. Okay, there's a negative, so there should be a negative. Let's just multiply with this whole thing to just get the previous answer back. So there's my mistake. Multiply with that. Then I'm back at the 8416,52 what. And I must just put a negative there in front of the 151. Okay, that's better. Right, so obviously with these things, that's a handy tip. You should also just always check that that the answers make sense, because the installment amount is not going to be a negative number. But now this still does not give me one minus one plus that. Okay. This answer still does not make sense to me, because the original installment was 11,000, and my installment should not be smaller. So I'm just quickly searching for my mistake there. 0.15 times 0.092 over 12 is that divided by 1 minus 1 plus 0.092 over 12 to the power of minus 151. Close the second bracket. There it is. For some reason it didn't work. Sorry about that. 29782. Right. So there is my final answer. That looks better, because obviously the amount is going to be more. Right. With these things, that's also a handy thing to know, is to check your answers for sensibility. And if you know, this does not make any sense, then you know you made a mistake somewhere, and you can just go check what the mistake is. I just pressed something wrong in my calculator there. But okay, so that is that. And that is question 5. Right, boys and girls, enjoy your week. And I see you next week again for Matric question Monday.